Hi, in this video we're going to talk about inequalities. The first thing to do is know what our symbols mean. We're going to write some inequalities in words. When you see these symbols here, it means 7 is less than 8. 7 is less than or equal to 8. Equal to 8, that's where we put the little bar underneath our inequality symbol. So less than or equal to has that bar under it. 25 is greater than 5. And 25 is greater than or equal to, again, we have that little bar to represent can be equal to. In the next few examples, we're going to rewrite the inequality, changing the direction of the symbol, but without changing the meaning of the statement. 7 is less than 8 has the same meaning as 8 is greater than 7. Notice we flipped the entire inequality around. This time, instead of starting with 7, we ended with 7, and the inequality sign is always kind of pointing in the same direction. Notice if you were to put a little line in it, it would look like an arrow pointing towards the 7. Again, same thing when we flip it around. The arrow still points towards the 7. Always points towards the lesser number or the smaller number. 25 is greater than or equal to 5 has the same meaning as 5 is less than or equal to 25. And x is greater than 3 has the same meaning as 3 is less than x. When we draw the graphs of our inequalities, which we're going to do to show the solution sets, we're going to use brackets and parentheses. So you always use parentheses when the endpoint is not included in the solution set. For example, when you have a less than or a greater than inequality sign. We use a bracket at the endpoint when we do want to include it. In other words, when we have less than or equal to or greater than or equal to symbols in our inequalities. We use a parentheses with every symbol representing infinity. At negative infinity, we'd use a parenthesis, and we'd use a parenthesis at infinity. We use this notation to represent the set of all real numbers in interval notation. When you're graphing an inequality, you draw a number line, you shade to the right or left of the number, and you write a parenthesis or a bracket at the number. So here's a couple of examples that I pulled out of MyLabs Plus. The first one, and the directions got cut off, but it says write an inequality using the variable x that corresponds to the graph of the solutions on the number line drawn below. Okay, so our number line, a lot of people like to always put 0 in the middle, and then we count positive numbers to the right. So this would be 1, 2, 3, 4, and it goes on out towards positive infinity. When we go to the left of 0, we count negatively, -1, -2, -3, and the arrow points towards negative infinity. So positive numbers always count out towards the right, negative numbers count down towards the left. On this one, 2 is my ending point, and 2, if you notice, we have a bracket here. So this tells me that this inequality is going to be either less than or equal to or greater than or equal to, because that's where I use a square bracket. And it's at 2, so if you look at the inequalities here, the inequalities all have to do with 2. So we need to know, is x going to be less than or equal to 2, or is x greater than or equal to 2? So you can pick a test number in here if you want to, or we can actually pick 2, one on the right and one on the left. Is 1 less than or equal to 2, or is 3 less than or equal to 2? So I'm trying to test out answer number B by plugging a number in for x. And in this case, 3 is not less than 2. 1 is less than 2. So in MyLabs Plus, you would just click on the little bubble there for B to choose your answer. Example number 2, this time we're given an inequality and asked to select the correct graph. So this inequality says x is greater than 3. So greater than, I know just from that we want to have parentheses in our answer. Okay, we're not going to have any square brackets. So I can eliminate answer choice A and I can eliminate answer choice D because those use square brackets. And the other thing I have to do is just pick now, which way does my shading go? Am I shading to the left or am I shading to the right of 3? So here again, I can just choose one graph to start with and I can pick some test numbers. I'm going to pick 0 and I'm going to pick 6 as my test numbers here. And I'm going to look at my inequality, said x greater than 3. Is 0 greater than 3 or is 6 greater than 3? And in this case, 6 is greater than 3, 0 is not. My shading should be going towards the 6 or towards positive infinity, so I know it's not answer choice B. My correct answer here is answer choice C. That's the correct answer. Now we're going to actually solve some linear inequalities. We're going to use essentially the same steps that we did when we were solving equations. Simplify each side of the inequality by clearing parentheses, fractions, and combining like terms. Then we use the addition property to get all the variable terms on one side of the inequality and the numbers on the other side of the inequality. And step 3, we're going to use the multiplication property to get the variable by itself. There's one difference here between equations and inequalities. So I want you to really pay attention to this bold text here. And when we get to this in a problem, I'm actually going to put a little star by it. When you multiply or divide both sides of an inequality by a negative number, you must switch the direction of the inequality sign. So if we think about this, 1 is, let me not use 1. 3 is greater than 2. Now if I multiply everything by a negative number, say negative 1, then I get negative 3 and negative 2. Now think about it. Negative 3 is less than, it's farther to the left on the number line. Negative 3 is less than negative 2. When I multiplied by a negative number, the entire direction of the inequality sign changed direction. And that's because when we have positives, 1, 2, 3, we're counting to the right. We're going to the right direction. When we go negative numbers, we're counting to the left. We change direction between positives and negatives. Step 4, you're going to give your solution as a graph and in interval form, and then you're going to check your answer. So we're going to work through some example problems here. So step 1, simplify. I have nothing to simplify in this one. Step 2, use the addition property. I want to get all of my x terms on one side. I only have one x here. Means I have to move my number to the other side. Positive 7 means I'm going to subtract 7 from each side of my inequality. And remember, instead of an equation now, we have an inequality sign. So that's our dividing line between the right and the left-hand side of our equation. Leaves me with x, because 7 minus 7 is 0, is less than 10 minus 7 is 3. Now I was not dividing by a negative here, I was just subtracting a number, so my inequality sign stays in the same direction. X is less than 3. I'm going to draw my number line. 0 and positive numbers go out to the right, and I go towards infinity to the right and negative infinity to the left. X is greater than 3. So here's 3, and I can pick two test numbers. I can pick a number to the right and a number to the left. Is 1 less than 3 or is 4 less than 3? It's not 4. 1 is less than 3, so it tells me I want my shading to go in that direction. And if I look at my inequality symbol, less than means I'm going to use a parenthesis here. When I write my interval off of that graph, I'm looking at the left-hand side. What do I have at the left? And what do I have at the right of my shaded region? Okay, so negative infinity to 3, And then at negative infinity, I always use a parenthesis. And this time at 3, we said we were using a parenthesis because it's less than. So there's our graph and the interval for that inequality. Negative 3x is greater than or equal to 15. So this time I have negative 3 times x. Multiplication means I'm going to divide both sides by negative 3. Oh, what am I doing? I am dividing both sides by a negative. So I have to change the direction of the inequality this time. Negative 3 divided by negative 3 is 1 times x is x. I've got to flip this inequality sign. This becomes less than or equal to 15 divided by negative 3 is negative 5. Then I draw my number line. I'm not going to put units of 1 on here this time. I'm going to go by 5s. And I go positive numbers to the right, negative numbers to the left. Now here's my negative 5. I can plug in test numbers to see which way am I supposed to shade. Is negative 10 less than or equal to negative 5? Or is 5 less than or equal to negative 5? Well, that's false, so I know I'm shading to the left. And this time I have less than or equal to, less than or equal to. I'm going to use a square bracket at negative 5. And again, my interval, I'm looking at my shaded region here, my shaded area. So the left-hand side of my shaded area to the right-hand side of my shaded area, I'm starting at negative infinity and I'm going to negative 5. Always a parenthesis with infinities. And this time we said it can be equal to, so we're using that square bracket at negative 5. Example number 3. Negative x. I don't want negative x, so I'm going to divide both sides by negative 1. And again, that's where I need to change the direction of my inequality sign. I get x is greater than negative 17 divided by negative 1 is positive 17. Draw the graph. Negative infinity on the left, positive infinity on the right. And this time I'm going to count by tens on my number line just to make it a little bit easier on myself. And I can always go back and identify 17 would be right about there. X is greater than 17. 20 is greater than 17, so I know I'm shading to the right. No equality on that sign, so I'm going to use a parenthesis. And again, I look at my shaded region from the left to the right of my shaded region. And I'm going to have parentheses 17 to infinity with a parenthesis. Example number 4. Here I do have some simplifying to do. First thing I'm going to do here is distribute to get rid of my parentheses. 2x minus 2 times 5 is 10, plus 3 is greater than or equal to 9 minus 2x. And then I have some like terms here. I'm going to combine those. 2x minus 10 plus 3 is minus 7. Now I need to get all of my x terms on the same side. I'm going to add 2x to each side of my equation. Not my equation, my inequality. And I get 4x minus 7 is greater than or equal to 9. I need my numbers on the other side. Minus 7, I'm going to make it plus 7. And that gives me 4x is greater than or equal to 16. And to get x by itself, we divide by 4. It's a positive 4, so the inequality sign stays the same, and I get x is greater than or equal to 4. Going to draw my number line. And this time I'm going to count by 2's. So here's 4. I want x greater than or equal to 4. 6 is greater than or equal to 4, so I'm shading to the right. I have equality here, so I need to use that square bracket at 4, and my interval bracket at 4 out to infinity with a parenthesis. Remember, order is important when you're doing your intervals. The next thing we're going to talk about are three-part inequalities. Three-part inequalities have two inequality signs. So if we look at example number 1, you have two inequality signs here. You have the stuff on the left, the stuff in the middle, and the stuff on the right of those inequality signs. So that's where we get the three parts from, the left, the middle, and the right. Example number 1, we have x by itself in the middle. That's always our goal, is to get the x by itself in the middle. So this one, we're just going to do a graph and an interval. And I just label my number line to go a little bit beyond the numbers in my inequality. Now, this says x is in the middle of -2 and 3. So my shaded region goes from -2 to 3. It's the part in between those two numbers. If I look at -2, I have a less than sign, means I'm going to use a parenthesis. At 3, I have a less than sign. I'm going to use a parenthesis there as well. So my interval is from -2 to 3 using parentheses at both endpoints. My next one, again, it's already solved. I have x in the middle. I'm going to count by 2's this time. And I want the region between 6 and 2. Between 6 and 2. There's my shaded region. Now notice at 6 you have a greater than or equal to sign. Equal to, that's where we're using that square bracket. Greater than sign, we use a parenthesis. So it doesn't matter what order the inequality is written in, our number line still has to go negative numbers to the left, positive numbers to the right. We have 2 with a parenthesis out to 6 with a square bracket. And now we're going to do a couple of examples. Again, our goal is to get x by itself in the middle. I'm going to add 4 to all three parts. And this gives me -3 is less than 3x is less than or equal to 12. To get x by itself in the middle, I need to divide all three parts by 3. And that gives me -1 less than x less than or equal to 4. I'm going to draw the graph on the number line. And I want to shade the region between -1 and 4. X is in between -1 and 4. At -1, we have a less than, so we use a parenthesis. At 4, we have less than or equal to. We use that square bracket. And our interval goes from -1 to 4. Parenthesis at -1, bracket at 4. Example number 4. Again, we're trying to get x by itself in the middle. I'm going to subtract 1 from all three parts. And that gives me -11 is less than or equal to 3x is less than or equal to -3. Divide all three parts by 3. And I get -11/3 less than or equal to x less than or equal to -1. Now in MyLabs Plus, when you do the answers, you want to keep your answers in fraction form. But sometimes it's easier. Negative 11 thirds is negative 3.7 approximately. Sometimes it's easier to draw your interval using those numbers. So negative 11 thirds is going to be right about here on my number line. I want to shade the region between negative 11 thirds and negative 1. Notice we're using brackets at both endpoints this time. So negative 11 thirds to negative 1 with 2 brackets. And that concludes this video. Have a great day.